Well, I'm delighted to be here. Let me first ask, can people hear me okay? Okay, good. If I fade off, please speak up. Let me just extend a sincere thank you to Ken and the folks at IHMC for this invitation. There's quite a impressive list of speakers that come before me, so it's truly an honor to be here. And I'm really blown away with this institute in terms of its culture of innovation and big thinking. You know, I live primarily in academia, and despite a lot of talk about interdisciplinary research and all the power in that, the foundation of the silos in academia are pretty strong. So it's easy to talk about, harder to actually do, but it's amazing what's happening here. It's a great model for any institute. So I've been studying very low carbohydrate diets for about 15 years, and what I've come to learn in that time is that a well-formulated, very low carbohydrate ketogenic diet is a huge hammer. And when you understand how to wield a very powerful hammer, everything starts to look like a nail. And so what I'm going to talk to you today about is keto adaptation, which is really the process of adapting to a very low carbohydrate diet and the various applications of that unique metabolic state. So we're wrapping up a remarkable decade of research on low carbohydrate diets, but despite that, low carbohydrate diets remain a fringe concept. And so I wanted to address this right off the bat because it's one of the most common questions I get. When you show people all the science, they'll say it's all very impressive, but why don't these diets get more advocacy, and why aren't they promoted? And I'm not going to go through all of these, but here's 7 bullet points here to think about a bit as to why maybe they haven't been considered more seriously than they have over the last 3 to 4 decades. And perhaps think about the political forces, if nothing else, at play here. Politics trumps science every day. And consider this viewpoint from famous geneticist Haldane talking about the stages that new theories go through. So step 1, this is worthless nonsense. Step 2, interesting but perverse point of view. Step 3, well, maybe true, but not that important. And step 4, I always said so. I will tell you, some of my peers who have, in the last couple years even, condemned low carbohydrate diets are now backing into low carb, and I suspect some of these people may actually claim they invented low carbs. So the Swedes here are surprisingly way ahead of the curve on us. This is sort of a news flash. Just within the last 2 to 3 weeks here, Sweden is officially the first country to flip, in that they have embraced the low carbohydrate, high fat diet as their national guideline. And this wasn't a trivial process. According to the reports, they reviewed 16,000 studies over a 2-year period. And so they had some pretty vigorous debate about this. But I think this is not trivial. Now, don't hold your breath. I doubt the United States is going to be changing their dietary guidelines anytime soon. But this will just give you a sense as this really has some momentum now. So at risk of stating the obvious, in terms of stating the problem, we have an epidemic, really a pandemic of obesity. And along with that, we have incredibly alarming rates of diabetes and other complications of obesity. But we've got about 1 in 3 adults in the United States are obese, and about twice that number are overweight. And that's despite a proliferation of programs and policies and task force to combat obesity. So we have no clue really how to slow this down. And that's really what's disturbing, is that if we look at trends and projections, we're in real bad shape here. If half of Americans by 2030 are overweight. Oh. Thank you. Okay. Is that okay? Can people hear me? And one of the real concerns here is the healthcare cost associated with this. I mean, estimates are north of $200 billion we spend annually on managing obesity. So what are the solutions? Well, we're just a bunch of lazy people, right? We just need to get out and exercise more. That's a pretty universal message. And I don't want to talk a lot about exercise, but I do have this one slide I think has some important information. This was a relatively small but incredibly well-controlled study done by Claude Burchard, published over 15 years ago. They did this in identical twins, so same DNA, and they had them exercise twice a day for 2 hours. And they burned an extra 600 plus kcals per day. So pretty rigorous. And this was in a metabolic ward, so they were being watched and they were being fed a diet that should have maintained their calories if they weren't exercising. So they were basically burning an extra 600 kcals per day. When you look at the actual weight loss, this is what you get. Tremendous variability here under the most highly controlled conditions, so no cheating here. Now think about this poor pair of twins here. They busted their hump for 2 hours a day and basically lost no weight. And there are a couple pairs of twins did pretty well, and you've got some that did okay. The real point here is that there's tremendous variability between twins, but there's a high degree of concordance within twin pairs. And so what this tells us is that exercise is not a very potent weight loss tool. Now, I don't want you to go home from this lecture thinking you shouldn't exercise. But it's not a particularly good message to tell obese people to exercise more. In fact, in a lot of cases, it's punitive. But exercise is a good wellness tool, and there's plenty of reasons exercise has health effects. But for an obese person, they have to address the diet and get their metabolism fixed, fix their fuel flow problems. And then once they've lost the weight and they have the energy, they naturally want to exercise and gain some of the health benefits. But it does depend on your DNA and whether or not you'll respond to exercise in terms of weight loss. So exercise isn't to sort of save all here. What else might be? And I think I really have the answer here, folks. I had an epiphany last night. And I don't see any flaws in this reasoning. We've raised the BMI from 30 to 35. Overnight, we cut the obesity rate in half. So seriously, where did we really go wrong here? I mean, if we look at the last 4 decades of our dietary policy, it can be described as nothing short of an epic failure. And I think part of the reason is we are promoting a unitary dietary intervention for a heterogeneic population. So in other words, we are promoting a one-size-fits-all approach. And I would argue that one size doesn't even fit the majority of the population. So we need better solutions. And pardon my stealing of Ken's blue sky word, but this is sort of my blue sky thinking in terms of what needs to be done. And granted, it's incredibly complex, but it's only complex because we don't understand it. I mean, the real answers lie in personalizing diet and understanding the factors that contribute to the variability in how people respond to diet. But that means we get exercise and nutrition folks and experts working with geneticists and microbiologists and computational biologists and bioinformatics folks, and ultimately translating all that discovery into real outcomes that the average person can then use. And we're infantile in our understanding of all the complexities here, but That's part of the reason I'm really intrigued by the model here of interdisciplinary research, because this is what it's going to take to really move forward this idea of personalized nutrition. And just to sort of underscore the complexity here, when we talk about how people respond to diet, you sort of have this cosmic collision between all the nutrients that you eat, even in a single meal. You've got different ratios of the macronutrients, not to mention dozens of essential vitamins and minerals, and not to mention all sorts of non-essential but bioactive phytonutrients in food. So you're eating these in all sorts of different proportions, and ultimately they're interacting with your unique DNA, and that's manifesting in some phenotype, in some response. And that is incredibly complex, much more complex than sort of the work being done with drugs, which are relatively simple in that there's one little chemical that's generally acting on a small target or a couple targets. Here, you've got much more complexity. So this is not easy stuff. And my initial interest in this area was looking at genes, and that's where a lot of the existing interest still lies. And in short, we didn't really get very far with measuring a wide variety of SNPs, single nucleotide polymorphisms in genes, because it just didn't predict the response to diet that well. So where do you really start with all this complexity? And I would argue that starting with carbs makes a lot of sense. So beginning to understand how to personalize carbohydrate intake is an area where I think we can actually make some significant traction. And part of the reason is carbs are more than just fuel. I mean, that's what you read in the textbooks and you're taught, and it's true. But more than that, carbs are a potent regulator of metabolism in that they control how your body burns fat. And what I mean by that is when we eat carbohydrates, because we don't store them in appreciable amounts, a little bit in glycogen, we therefore have to get rid of them somehow. And the way we get rid of them is we burn them for fuel. But a lot of people don't burn them very well, so they end up converting them to fat too. But the bottom line is that this type of metabolic response locks people into a storage mode, where if you're overweight or obese, your problem isn't calories in, calories out. Your problem is you store an excess amount of energy in your fat cells. And that's a subtle difference, but an incredibly important one, because if that's the problem, logically the answer involves understanding what controls access to your fat cells. And that's insulin. And insulin's tied to carbohydrate. So carbohydrates control fuel use, and in particular, it inhibits access to fat. Nevertheless, in the population, you can see a wide range of tolerance to carbohydrates. Some people do fine on high carbs, some don't. And if you're thinking, a low-carb diet's sort of extreme or unbalanced or violates this ideal of moderation that we have, think about it from the evolutionary perspective, where during the majority of human history, we've evolved in the context of a diet that was relatively limited in carbohydrates, at least during most of the year. And so it's not that difficult to imagine that we still retain all this metabolic machinery and programs to deal with a low-carb diet. And that's what I'm trying to show here. When we slide people up and down in carbs, basically you get a lot of variability, but you get a whole lot more variability in response when you increase carbs, such that a lot of people will develop metabolic syndrome and type 2 diabetes. But when we bring people down to very low levels of carbs, sort of keto adaptation, it's a rather uniform response, suggesting that it's a very conserved trait to respond properly to a ketogenic diet, even if you have profound insulin resistance. So let's switch gears a little bit, and this graph shows the dietary patterns over the last 4 decades from N. Haynes, arguably our best data source on food intake. And so we've really not changed our intake of protein and fat to a great extent. If anything, we've decreased our fat intake slightly, and that's what we've been told to do. Clearly, the most salient change has been a marked increase in carbohydrate to the tune of about 200 additional kcals per day, and that's probably not, fibrous vegetables here. It's just sugar and processed, quickly absorbed forms of carbohydrate. And the question is, should we be concerned about this extra carbs we're consuming? And I would argue, yeah, we should be concerned. But let me ask, there's a lot of smart people in the room. How much total sugar do you have in your bloodstream right now? Any ideas?
The wine.
Let me rephrase. In gram amounts here of carbohydrate, or even teaspoons or tablespoons, whatever unit you prefer, we'll convert. 30 grams is pretty high. It's actually about 2 teaspoons, 1 teaspoon being about 4 grams. So you'd be pretty diabetic if you had 30 grams. But it's not that much. I mean, consider not even a large meal, but an average trip to Starbucks. You grab a bagel and a low-fat latte, and right off the bat, you're at 10 times the amount in your blood. So, that puts a bit of a stress on the body to process that because we can't store it that well, remember? So I'm going to dip a little bit into metabolism here. I won't go too far. But when you ingest carbohydrates, so say you just had that meal that contained 10 times the amount in your blood, a healthy person primarily takes up that incoming carbohydrate into skeletal muscle, where it's eventually oxidized. It might be converted to glycogen first, and that would be considered more or less a healthy disposal of carbs. But if you're insulin resistant or carb intolerant, a greater proportion of that incoming carbohydrate goes to the liver, where it's converted to fat. That process is called lipogenesis, the formation of fat from non-fat sources. So carbohydrate can be converted to fat, and that happens in generally people who are overweight or insulin resistant. And when that happens, the liver actually makes fat and releases it as VLDL particles, and it actually makes a saturated fat, palmitic acid. So I'll come back to that. But in particular, saturated fats go up when you overconsume carbs relative to your tolerance, and so does this particular fatty acid. And this is not really benign. You can imagine continually having these repeated insults where you're converting more and more carbs to fat. Ultimately leads to a cascade or a ripple effect where you have potentially a lot of collateral damage occurring, leading to metabolic syndrome and type 2 diabetes. And so I would argue this alternative or secondary path of carbohydrate is a form of carbohydrate intolerance. And I like to use that term to describe the condition because it's almost intuitive what a solution would be. And so the idea here is that insulin resistance, which is incredibly complex, and there's billions of dollars being thrown at trying to understand this, really functionally manifests itself as a form of carb intolerance. And if you're lactose intolerant, what do you do? You restrict lactose to a level you can tolerate. If you're gluten intolerant, you restrict gluten. Well, if you're carb intolerant, it makes sense you would restrict carbohydrates. And so an important principle here, though, is that people vary widely in their ability to process carbohydrates in a healthy way. If you happen to be a person who can metabolize carbs, you have more options. You can do well on high carb or low carb or moderate carb. But if you have any of these conditions, it's likely you're going to need to restrict carbs to some level. And along those lines, you can think of type 2 diabetes in particular then, which is, the cardinal feature of type 2 diabetes is insulin resistance, as a side effect of consuming too much carbohydrate. And the last part here is important, relative to your tolerance. So I can't say that this is a specific level of carbohydrate universally because it does depend on the level of tolerance, which varies. And this is not trivial in terms of how many people this affects. If 3/4 or 2/3 of the people in the U.S. are overweight, it's likely they have some level of insulin resistance, and I would argue they're not well suited to the current dietary guidelines, which promote low fat. And when we look at this globally, we're talking about hundreds of millions of people that probably would benefit significantly, especially type 2 diabetics, from restricting carbs. So is there any evidence this actually works in research studies? And the answer is yes. I'll show you one example here. This is a relatively well-publicized study back when it was first published in JAMA called the A to Z study, done by Chris Gardner out at Stanford. And it compared Atkins' diet to Ornish and a couple other diets over a year period. And they basically showed the Atkins diet was superior to these other diets in terms of weight loss. And that was interesting, but the more, I think, provocative result came a few years later where they went back and did a retrospective analysis and put the participants into tertiles based on their level of insulin resistance. And they compared the two extreme diets, the low-carb Atkins and the low-fat Ornish, high-carb. And basically what they showed was that if you were randomized to the low-carb arm, it didn't matter if you were insulin resistant or insulin sensitive, you lost a significant amount of weight. But if you were assigned to the Ornish low-fat diet, you did well if you were insulin sensitive, but if you were insulin resistant, you didn't lose much weight at all. So that sort of confirms this idea of carbohydrate intolerance. Basically means you've got to restrict carbs to some level. So another way to sort of look at this whole scenario is from a metabolic perspective. And in many ways, what we're talking about here is switching from a carb-based metabolism to one that's almost exclusively based on using fat or lipid as fuel, in particular fatty acids and ketones as your primary fuel. And an important point here is that diet, more specifically the carbohydrate in your diet, is by far the dominant factor that can drive this dominance in terms of fuel use. And there's a lot of research, basic science research going on in terms of fuel use. So we know, for example, cancer cells that are based primarily on glycolytic metabolism basically they do well, they proliferate on this type of metabolism. But when we switch their metabolism over to fatty acids and ketones, we basically are seeing regression of tumors. And we're seeing all sorts of evidence that this type of metabolic shift is associated with life extension and reduced oxidative stress, more or less anti-aging. So there's a lot of basic science and cellular adaptations associated with this type of metabolism that are all positive. And that's where my interest lies in how does all this play out when you shift a person over to a fat-based metabolism in terms of various health markers and even performance. And so I have a lot of fun in the lab because we get to study, people who have type 2 diabetes and pre-diabetes on one end of the spectrum, but on the other end we're studying some of the most elite athletes, world-class athletes, and how they respond to shifting their metabolism as well. And I'll share a little bit with you in terms of different sort of spots on that continuum. And if you don't believe that carbohydrates regulate fat metabolism, here's the sort of most important graph, I think, that shows that. So you've got insulin concentration on the x-axis. This is basically fat breakdown here. And you see that the relationship is not a straight line. It's, in fact, a curvilinear relationship such that in this range here, just small reductions in insulin translate into huge changes in fat breakdown. So if you decrease your insulin just a little bit, and this is well within the physiologic range, you have a dramatic impact on fat burning. So when you eat sugar or starch, you get a rapid increase in your blood sugar. And of course, that causes your pancreas to secrete insulin, so you get an insulin surge as well. And of course, that tends to result in this rebound low blood sugar or sugar crash, and that we all know that doesn't feel well, and you're tired, and that's, when you put your head gently down after lunch and try to take a little nap, or you go and seek out carbs, more carbs, to bring your sugar back up. So that's obviously not good. But what's more insidious here is the insulin spike that accompanies the sugar spike, because as I said, that is blocking access to fat as fuel. And for people that are trying to lose weight, that's exactly what you're trying to burn down. So I want to now transition into ketosis. And ketones are incredibly misunderstood metabolites, even by most physicians and healthcare professionals. The truth is, ketones are a natural part of human metabolism, incredibly important aspect from an evolutionary perspective in terms of providing a fuel source for the brain during periods of prolonged starvation. Basically allowed us as Homo sapiens to develop big brains, which is probably the most unique aspect of our species. So that when I talk about ketones, I'm referring to beta-hydroxybutyrate and acetoacetate. They're produced in the liver when carbohydrates are limited. And we largely all have the capability of producing ketones. It's just that most of us, unless we're following a low carbohydrate diet, that program is being suppressed because of the carbs we're eating. So it never gets a chance to boot up and run. It's a software program that's just sitting there dormant unless you unleash it by restricting carbs. And one of the most important functions of ketones is to provide fuel for the brain. So in a normal fed state, the brain is a glucose-dependent organ, getting almost exclusively all its energy from carbohydrate or glucose. But in ketosis, more than half of the energy, perhaps up to 2/3 or 3/4 of the energy the brain needs comes from ketones. And the brain's pretty metabolically active organ. I mean, it burns about 600 kcals per day just being a brain. And so that's roughly 150 grams of glucose it requires, unless you have ketones circulating around. So this is really important effect because now you have a very stable and sustainable fuel source for the brain. And this is just some terms because people get confused. So ketones are these metabolites that our liver makes when carbohydrates are limited in the diet. Ketosis is that process by which the ketones are generated. And there's no real threshold here, but we tend to use this as sort of a threshold to define when a person is in ketosis compared to most people in the fed state are below 0.1. So now we're at 0.5. And so we call this gradual increase in ketones nutritional ketosis. In contradistinction to ketoacidosis, which is where a lot of the negative connotations of ketones come from, because that's a very serious condition where when insulin is insufficient, so this is in type 1 diabetics, ketones are allowed to accumulate to levels that do become acidic and can be toxic. But in nutritional ketosis, in someone who has basal levels of insulin, this never happens. So unless you're a type 1 diabetic, you don't have to worry about levels this high. Unless, of course, maybe you're supplementing with large amounts of ketone esters, which gets into another whole aspect of this research. Keto adaptation, then, as I talked about, is really this process of adapting to a low carbohydrate diet, which we've learned does take time. It takes a couple weeks or even months for all these adaptations to occur. And so this just kind of shows you the range of ketones. We're talking about nutritional ketosis starting at about 0.5 and extending perhaps out to 3, 4, maybe 5 millimolar. Contrast that with ketoacidosis, which is really 10, 15, 20 millimolar. And this is a fascinating study that I just wanted to show because it's a study you probably won't see replicated because of IRBs. But this was a study done by George Cahill, who did a lot of the elegant experiments on ketosis. He took a group of people who had been starved for 4 weeks. And you can see they had very high ketone levels here, around 5 millimolar. And then infused insulin into these people, such that their fasting blood sugar levels, which were normal, 70 milligrams per deciliter, plummeted to levels, in some cases they reported, below 20 milligrams per deciliter. Now, to put that in perspective, if you're not from a medical background, if you have a level in that range with 20, 25, you would almost surely be in a coma and probably die. The body doesn't tolerate that level of hypoglycemia unless you have ketones around. So these people who had this level of glucose showed absolutely no signs or symptoms of low blood sugar. They were perfectly fine. So there is this profound protection against some of the signs and symptoms of low blood sugar when you're in a state of ketosis. And this plays out in important ways for athletes in terms of preventing hitting the wall, which is essentially a fuel crisis in your brain. And it plays out even in type 1 diabetics, who a major problem in type 1 diabetics is nocturnal low blood sugar. So they often have episodes of hypoglycemia during the night and other clinical conditions. So we've also learned a lot about ketones more recently in terms of their metabolism and some other provocative effects. So one way to think about ketones, I like to describe them as clean burning fuel. And by that I mean they don't generate as many free radicals as other nutrients do when they're being burned. So there's less generation of these reactive oxygen species or free radicals. It's also been shown that they are more efficient in providing ATP or energy. So you get more ATP and more total work done when you're burning ketones relative to other fuels. And I think one other extremely important study that was published just last December in a little journal called Science that showed essentially ketones were acting as epigenetic modulators of metabolism. Now that's a mouthful. Basically what that means is ketones were acting as signals to, in this case, increase gene expression of a whole array of antioxidant genes that protected against oxidative stress. So sort of independent of their role as fuel for the brain and other tissues, they were regulating metabolism. And then, of course, they worked out the mechanism through histone deacetylase inhibition. And let me tell you, almost every pharmaceutical company has their pharma development teams trying to develop drugs to inhibit histone deacetylases. And I know you can't see this very well, but the effects of ketones in this study were profound, such that if this was a drug, it would be a blockbuster. So getting a little bit into the science of low-carb diets, I've been in this business for a while, and it's nice to see that people are somewhat catching up here. These are all review papers in the last year. I think this is all 2013. And they're all more or less coming to the same conclusion that low carbohydrate diets are at least as effective, usually more effective than low-fat diets for treating a variety of conditions. So not just weight loss, but improvements in cholesterol metabolism and insulin sensitivity, blood pressure, inflammation. And this is despite the fact that most of the studies out there are pretty sloppy. It's actually pretty hard to do good diet research because it's hard to control that in a free-living population. Not to mention, a lot of these researchers don't really understand a lot of the nuances of of formulating a low carbohydrate diet. But even despite all that noise and slop, low carb diets usually do better than low fat diets. And when you find studies that are well controlled, the results are even more striking in terms of the benefit. And I don't want to show you a lot of data, but just to give you a sense of the array of different biomarkers we've looked at, this was a study comparing a very low carbohydrate diet to a low fat diet in a group of patients with metabolic syndrome. And they lost more weight, they lost more fat, they get a profound reduction in triglycerides, and HDL goes up. We've done extensive lipoprotein profiling. Glucose goes down, insulin sensitivity improves, leptin levels go down. And this is really fascinating, and I want to spend a little bit of time on this. Saturated fat levels go down in the body. And I'll come back to that. But basically, any biomarker we've measured tends to improve more on low carb than low fat. And we've done a lot of postprandial work, so we'll feed people fat, measure fat in their blood for 6 to 8 hours. And you see, before they go on the diet, these people get really hyperlipidemic when you feed them. We give them like 1,000 kilocalories of fat and see how they process it. We give them that same fat load 12 weeks later, and you see much more efficient processing. So there's clearly a really important adaptation going on over time. We've looked at a lot of different measures of vascular function. This is a longitudinal view of the brachial artery, and we've looked at functioning of that artery under these lipidemic conditions and shown that improves with a low-carb diet. We've seen multiple times now the low-carb diet reduces pro-inflammatory markers. So it seems to be inherently an anti-inflammatory diet. Now, coming back to this saturated fat story, despite all this really impressive science, there still remains a lot of concern about saturated fat because you tend to eat more saturated fat on a low-carb diet. And I just want to take a few minutes to really go over a very important point because few of the experts really get this, but it's not that bad. But if you actually look at the recent meta-analysis that have asked the question, is dietary saturated fat correlated to heart disease? Here's 3 of those meta-analysis. Pretty large number of studies, subjects studied in these 3 meta-analysis. They all came to the same conclusion, that there was no increase in heart disease or no association between saturated fat intake and heart disease. So that right there, sheds doubt on this whole diet-heart hypothesis. In fact, in this meta-analysis, they asked the question, if you restrict saturated fat, does it matter what you replace it with? And in this case, they showed if you replace saturated fat with carbohydrate, not only do you not get a benefit, it actually increases your relative risk of having a coronary event. And that isn't some strange hypothetical. That's actually what most Americans have done. They've decreased their saturated fat and increased their carbohydrate. But if you look at studies that have correlated how much saturated fat you have in your body and risk for heart disease, there is a pretty consistent relationship there. So the amount of saturated fat in your blood and in your membranes is important. And here's just 4 studies that show more saturated fat in your phospholipids in your blood correlate to increased risk for various heart problems. And I could show you another half dozen studies that show increased risk for diabetes and metabolic syndrome. So the story is a little more complex than just that. So the real issue is how much saturated fat you have in your body, not necessarily how much you're eating. So we did this 12-week study, put people on low fat or low carb. What I really want you to focus on here is the low carb diet had 3 times the amount of saturated fat than the low fat, 36 versus 12 grams. Despite that, when we measured saturated fat in their blood, it went down more. And we looked at this in different lipid fractions, and my colleague has done animal studies and looked at muscle and adipocytes and liver and all sorts of different tissues, and it's the same effect. So it's not just moving around to someplace else. So this is really profound. Ooh. And in particular, this fatty acid, which I'll come back to, this is palmitoleic acid, probably goes down more consistently with a low-carb diet than any other biomarker I've measured. And this is an indicator of conversion of carbs to fat. So that's going down. So here's sort of the paradigm that I want to explain. So let's say you're going out to eat and you want to enjoy your nice marbled steak here. And most of the time you get a baked potato with that, so you're getting a dose of carbs. So in this case, you know, you're basically setting yourself up in a metabolic state because of the insulin response where you might be processing that saturated fat in an unhealthy way, where it tends to be stored and accumulate and may even promote conversion of some of the carbs to saturated fat. And this is what's associated with a lot of the metabolic problems of metabolic syndrome and so forth. But if you say, please don't give me the baked potato, but give me 2 servings of vegetables instead, so you don't have a big insulin response here, now you've got a completely different response in terms of the saturated fat, because now you're in a state where you're burning the saturated fat for fuel. And it's really hard to imagine dietary saturated fat being harmful if you're promptly converting it to CO2 and water. That is, you're burning it or oxidizing it. And so you can get a completely different response. So the point here is the effects of dietary saturated fat are highly dependent on the carbs you're eating. And so the real soundbite here is that we are not what we eat. Despite our fascination with that aphorism, we really need to change it to you are what you save from what you eat. And so dietary saturated fat has very little correlation to plasma levels of saturated fat. Carbohydrates are much more the modulator of plasma saturated fat. So let's talk a little bit about some of the clinical applications real quick. The real obvious one here is type 2 diabetes. And the results of a well-formulated ketogenic diet in diabetes are nothing short of remarkable. You can not only prevent type 2 diabetes, you can substantially reverse it. And I'll just give you one example. This happens to be a study from Kuwait, who has the Middle East has the highest rates of diabetes, almost twice the rate we have in the United States. But this was a really well-formulated ketogenic diet. They provided extra fat, which most studies don't. And so the results, I think, are really true to what you can achieve with diet. And it was also long-term, so it speaks to the sustainability of the approach. But they lost substantial weight, substantial improvements in glucose, lipids, and hemoglobin A1C, profound improvements in type 2 diabetes. I think what's perhaps even more interesting now is cancer. We're now learning a lot more about the basic science of cancer, and that most cancers have tumors that are associated with problems in insulin signaling, and they have insulin receptors, and so it makes a lot of sense that if you sort of decrease glucose flux through these tumor cells, that would be a good thing. So there's not been much done in terms of human clinical trials, but my colleague Jean Fine published this small trial in women with breast cancer and showed positive results of a low-carb diet. I think what might have been even more important was that Lewis Cantley, who's a very prominent basic science researcher in cancer, wrote this editorial about the real need to do more work with low-carb diets in cancer. And there's a whole range of applications in neurodegenerative diseases. We've known for decades or even hundreds of years that ketogenic diets work nothing short of miracles in intractable seizures. But we're now learning that there's a range of other neurological diseases from Alzheimer's, Parkinson's, Lou Gehrig's disease, even autism and migraines, where the real basic science is very exciting. And I think over the next several years, you're going to start to see some clinical trials in humans really back up what we're seeing in some of the real more basic work. So in the last few slides here, I want to switch over to the other end of the spectrum where we're kind of studying really healthy people, athletes. So I took a group of my lab out to Western States back in 2012, which is a 100-mile race through the Sierra Nevada mountains. These guys are wired a little different, right, from the start. But it turns out there's a growing legion of these athletes who are switching to low carb. And the winner of that race that year was a guy named Tim Olson. And you can see his time here, maybe. If you can't read that, it says 14 hours and 46 minutes. He looked pretty fresh coming across, too. Some of the guys looked like they were just a few steps short of death. But, you know, that was a course record. He beat the course record by about 30 or 40 minutes, I think. And he's a self-proclaimed low-carb athlete. And it wasn't a fluke. He came back just this last year and won again. A little bit slower time, but it was incredibly hot. And it was in the mid-90s, so it's incredible that these guys even finished the race. And he's not the only one. There are, as I said, a real contingency of these athletes out there that are not just competing and winning races, they're setting records. And they're doing it using an approach that is completely opposite to what we perceive as being optimal for sports nutrition, which is, you know, we should be carb loading and taking all these sports drinks and gels. So we know very little about this in terms of what makes these athletes tick. So we're doing a study at UConn. This is where my lab is in Gamble Pavilion, and we're basically flying these athletes into our lab for 3 days and taking them through a battery of tests. It's pretty invasive, but amazingly, these guys don't mind being poked and prodded. They actually love being guinea pigs. So we're taking muscle biopsies and fat biopsies and infusing isotopes, stable isotopes to study fat kinetics and so forth. And it's nothing short of remarkable what we're finding. And I'll just show you one result here. So this isn't our data, but this is a well published study that looked at peak rates of fat oxidation in 300 individuals, including elite athletes with very high VO2 maxes. And basically my point here is that you'll be hard to find any data in the literature that shows peak fat oxidation rates, peak fat burning during exercise higher than 1 gram per minute. That seems to be the ceiling, or that's perceived as being the highest rates that humans can achieve. So we've brought 3 male pretty high caliber ultra runners into our lab, and this was their peak fat oxidation. So they're literally off the charts. This is a graph that I pasted. So they're about 1.5. This one we tested just a week ago generated about 1.8 grams per minute. So 50 to 80% higher than the assumed maximum. So this is really interesting. I mean, this whole process of keto adaptation and shifting to fat for fuel has tremendous application for athletes, for treating a variety of clinical conditions, and I would argue the soldier, you know, especially the special ops guys that are going out on sustained missions where, you know, they're apt to run out of fuel, and that's bad if they crash. But there's a lot of other, you know, potential reasons, both physical and cognitive, that being in a ketotic state could benefit the elite soldier. And I won't go through all these in the essence of time here. But I do want to just kind of bring up this concept again of personalizing the diet. So everybody asks me, how low do you have to go? And the answer is, it depends. And so some people will need to restrict carbs to 50 grams a day in order to elevate their ketones into the nutritional ketosis range. Other people who are more profoundly carb intolerant will need to restrict it to 30 grams. Some of these athletes may be able to eat 70 grams. So it really varies from person to person, which is why we advocate actually measuring ketones. And what I've been really interested in is finding out ways to understand how we can test biomarkers to know how people are processing carbohydrates, whether they're converting it to fat or whether they're generating a lot of oxidative stress because of the carbs they're eating. And we've actually identified some very responsive and sensitive fatty acids that do track that very well. And we're in the process of developing those as diagnostic tests that would be available for people. And I'm going to skip through that because it's a little technical, but I just want to leave you with the thought because I don't want you to leave here thinking, okay, this is great, but I could never follow this diet, because that's not really true. I mean, there are some challenges, and you have to have some knowledge about how to navigate through the minefield of carbs that are ubiquitous in the stores and in the restaurants and so forth. But this is a typical day, and this is pretty restrictive. And I don't know if you can see that, but that doesn't seem like you'd be sacrificing too much. And this is one of our feeding studies, one day of meals. And people love this. They actually prefer it to the high-carb diet. So this was one quote we had from a recent subject that, is not a strange response we get from people who are eating this type of diet. And so who would complain? All those foods you couldn't eat now you can have. I mean, this is not sacrifice. This is luxurious. So in summary, I think the key to our healthcare crisis and to improving people's health and in performance is really finding ways to individualize the carbs and individualizing the macronutrient profile. But we do need some objective help in a lot of cases. People don't naturally find this themselves, and I think that future we will have a lot of help in terms of feedback. And I like to use the analogy of we need to give people a personalized GPS. So you wouldn't leave your house not knowing where you're going without some directions. And you need turn-by-turn directions in terms of which foods to eat that are suitable for your metabolism. So let me leave you with this quote by a famous Nobel laureate. And I would say in respect to nutrition, he's pretty conservative, that it's more like 90% of what we think we know is wrong. So with that, as Harry Kissinger famously said, do you have any questions for my answers? Sure, in front.
Could you give us an example of what is 30 grams and 50 grams of carbs? Is like a baked potato. How many grams of carbs is?
That would blow you right there. So, but I mean, in terms of what foods you could eat, you would be able to eat a variety of non-starchy vegetables, a whole wide range of different types of leafy vegetables and salad-type vegetables, and that's a misconception. People think you can't eat those, but they're mainly fiber. All sorts of different meats, from chicken, beef, fish, eggs, cheese, cream, butter, olive oil, coconut oil, nuts, seeds. So it's a pretty impressive variety, and so you could still select within those food groups and be under 50 grams a day. So you're obviously avoiding grains and breads and pastas and sweets. You can even include some fruit. Some berries that are less than 10% weight in moderation generally can fit into a less than 50 gram per day diet. So it's not too bad. And believe it or not, you can live without bread. And sure, how about right next?
Is it possible to overdo the diet and waste away, or do you reach a plateau at some point where you don't lose more weight?
You will find that the diet has a very strong effect on appetite. So it's very satiating, which makes it actually one reason why it works so well, that you aren't so hungry, and that's why low-fat diets fail. You end up being so hungry. But generally, that's, that sort of self-regulates itself to a point where people don't continuously lose weight to a point they become, anorexic or something. That's just, there seems to be something built in when you get down to or close to your if you want to, I don't know, I like the term, but your sort of set point weight, the appetite kicks in a bit, and that's a really important transition, though, and that's where a lot of people get tripped up, because when they when they lose the weight and then they go into weight maintenance, you have to increase the calories. And the mistake a lot of people make is they add carbs back. And then they end up with all the same problems they had before. So what you have to do is really get comfortable with fat, because fat, you're really not going to increase protein. So you have to increase fat, and you have to really get comfortable with that and learn how to incorporate more fat without adding carbs and protein. Sure.
There's this thing about low calories extending life. So I'm wondering, I see the benefits of this high fat, low carb diet, but if you just had a diet in general, which maybe wasn't a high fat, low carb diet, but was way lower in calories, would that be equally as effective? Have you looked at that compared to this?
I mean, we haven't studied that directly, but it's a really great question. My feeling is, in my read of some of the basic science here in terms of what's been done with caloric restriction, is that it's activating the same transcription factors and signaling networks in cells that carb restriction does. So my feeling is you could get the same effect in terms of life extension, in terms of reduced oxidative stress, which is tied to the whole process, by restricting carbs without restricting calories. And I think people are starting to do those experiments now. You can imagine it'd be pretty easy to do. You know, if whatever your model is, whether it's C. elegans, worms, or mice, or whatever, you could feed one group a low-calorie, low-fat diet, and you could feed one a full-calorie, carb-restricted diet, and do these types of experiments. But I don't see a lot of those direct comparisons yet. But a lot of the signaling we know is mediated through insulin, which is carb-driven. So I think my prediction would be the results would be the same or even better with carb restriction. The waving man in the back.
Have any of your subjects had trouble with gout from the ketones competing with uric acid?
Yeah, the short answer is no. Uric acid does go up transiently on a ketogenic diet, but there's an important distinction here. The concern with uric acid is when it's produced intracellularly. And the reason uric acid goes up on a ketogenic diet is because of competition for excretion in the kidney with ketones. So they share the same organic transporters. And what we see is it can be a rather sharp increase, perhaps up to 50% increase, which does alarm some people. But after about 4 to 6 weeks, it tends to come back down into a normal range. And so again, it's not because of increased production, though. It's just because it's not being cleared at the same rate. So we don't see any exacerbation of gout in people that are, predisposed to that. So we don't view that as a contraindication for the diet.
I'm not optimistic, no, but thank our speaker.